let's look at the vector statement. If I had some variable h times the vector a and made that equal to some variable k times the vector b. In fact, both these variables could be considered to be the scalar multiples of the corresponding vectors. So h is the scalar multiple of a and k is the scalar multiple of b. Now both a and b are parallel, so a is parallel to b if h and k are equal to some value. Because if that was the case, for example, if h was 3 and k was 2, then I'd have 3a is equal to 2b, and those two vectors are in parallel to each other because they're in some relationship that involves a scalar multiple. So one is the scalar multiple of the other. The only case then where we'd have vector a and b not being parallel is in this case if h was equal to k and both of them were equal to 0, then we can say that a is not parallel to b. And to look at that in more detail for another example, if I had the example then that lambda a was equal to 5 mu b, so I have this situation here, for what values would lambda and mu be, both scalar multiples, so that these two vectors are not parallel? Well, for the vectors not to be parallel, so not parallel, I'd need that lambda was equal to 0 and mu was equal to 0. Likewise, if I had another situation where I had lambda a take 2b is equal to mu b plus 5a, first off I need to get all of my vector a's on one side and all of my vector b's on one side. So this would be lambda a, bringing this one over becomes take 5a, and that's equal to mu b, and take 2b, bring it over this side, becomes plus 2b. I can now take a factor on both sides of their corresponding vector out, and I have lambda take 5a is equal to mu plus 2b. And again, as I said, for them to not be parallel, both of these parts here must be 0. So lambda take 5 is 0, therefore giving that lambda is equal to 5. And mu plus 2 is 0, therefore giving that mu is equal to -2.